So now we're going to talk about sleep. For some people, sleep is an enigma. And I always love to start off with this quote, and it shows you how long people have really wanted to been able to sleep. And the quote is from Shakespeare's play Henry IV. He writes, "O sleep, O gentle sleep, nature's soft nurse, how have I frighted thee, that though no more will weigh my eyelids down, and sleep my senses in forgetfulness." Folks, for hundreds of years, probably for millennia and even more, people have had difficulties with sleep. But what is actually sleep? Why do we sleep? Let's talk a little bit about sleep and some of the aspects of what happens when you don't get enough sleep. I think that will also answer the question and why it is that we need to get sleep, how much sleep, and what's the best way to get sleep. That's what we're going to try to cover here in this topic. So we know that sleep deprivation, when you don't get enough sleep, affects memory, cognition, that's your ability to think, and motivation. And the effects are compounded when you do this for a long period of time. Let's talk about adolescents. These are the people that we think sleep the best. But when adolescents don't get sleep, there can be some very serious consequences. Consequences like depression. We know that adolescents tend to fall asleep later, and that school starts very early. And so they're susceptible to these types of things. They would rather wake up later in the morning. But what about for us as adults? Well, if we look at high school students, for instance, 87% of high school students in the United States get far less than the recommended 8 to 10 hours of sleep. Right now you're saying, Dr. Schwell, are you saying I should be getting 8 to 10 hours of sleep? No, that's what's recommended for teenagers. For adults, it's at least 7 hours. We'll talk more about exactly how many hours of sleep you should get, but just to think about that, what are you getting in terms of your sleep, and are you getting enough sleep? In fact, 55% of all fall asleep crashes were caused by drivers under the age of 25. It's very interesting is that you can have sleep deprivation in an adolescent, and you can have sleep deprivation in an older adult. And what's known is that the older adult will do a better job of covering up the consequences of sleep deprivation. And that's a good thing in some sense, but it's also a bad thing because I see a lot of patients in my sleep clinic who, on paper, are clearly, when all of the objective information comes in, it shows that they have sleep deprivation, but they feel fine. But the effects of that sleep deprivation are going on in their body. So research has shown that sleep problems among adolescents are a major risk factor for suicide and also depression. And it ranks as one of the top reasons for suicide and death in that age population. If that's what it is for them, what also could it be for people who are not adolescents, teenagers in high school, people who have jobs, getting up early in the morning and commuting? How is this sleep problem occurring, and what can we do about it? All right, well, let's talk about sleep a little bit. One of the things that you have to understand about sleep is the drive to sleep. And just like there were two aspects of our immune system, there are also two aspects of what makes us sleep. So let's talk about those two things. The first thing is something called the homeostatic drive. Homeostasis is something that we're all familiar with. If you're thirsty, you drink water, and now you're not thirsty. If you're hungry, you eat food, and then you're not hungry. It's the same thing with sleep. The homeostatic drive for sleep basically says that when you wake up in the morning, you have the lowest drive to sleep. And as you go throughout the day, a substance called adenosine builds up and causes you to be more and more sleepy as you go throughout the day until finally you go to bed at night, and what happens? You start to satiate that need for sleep, and it goes back to the lowest aspect when you wake up the next morning. But there's more to it than just homeostasis. You know this, right? I mean, you know that when you wake up in the morning, you should feel well rested, but you don't get increasingly sleepy as you go throughout the day. You get sleepy right before you get to bed normally. So there's more than just the homeostatic drive, and that's something called the circadian rhythm. So the circadian rhythm is really important in terms of making sure that we stay awake until we're ready to go to sleep. And as you can see here on the graph, the green bar, as we just talked about, is the need for sleep. That's the homeostatic drive. It increases as you go throughout that middle period of the day, which is daylight. But also notice that the circadian rhythm also tries to keep your need for sleep very low throughout the day, except for that little bump in the middle there, which is around noon. This is a little siesta. But notice that as that red line goes up dramatically towards the end of the day, that's when you start to feel sleepy. So the thing that you have to understand here is that that circadian rhythm, that circadian drive, is dependent on where your clock is. Every one of us has a clock in our brain that's regulated by something called the suprachiasmatic nucleus, which we'll talk about. And depending on if that thing is shifted one way or the other, it can make you feel like you want to go to bed early or make you want to go to bed late. The point is that if that circadian rhythm is not perfectly aligned with what's going on in your life, you're going to have hypersomnia, increased sleepiness, or insomnia, not be able to go to sleep. And so it's important that that be in line with each other. So again, what are the two things that determine whether or not you go to sleep? Homeostatic drive, and that basically has to do with adenosine building throughout the day. That's the green line. And also the red circadian rhythm, which is imprinted in your mind but can be shifted back and forth. So what determines how this circadian rhythm is met out? How do you determine whether the circadian rhythm is in line or not in line? Well, that has to do with this graph. And what you can see here is that light is coming in through the eye, and light is one of the major arbiters of where that circadian rhythm is going to be. And one of the things that you have to understand both in this talk and also when we talk later about light and sunshine is that light hits the retina and it is projected through neurons that go to the suprachiasmatic nucleus that you can see there. They're the SCN in red. And then basically will determine whether or not your circadian rhythm is delayed or advanced depending on what time of day you get this light in the eye. So let me just repeat that again. Is light coming into your eye is going to stimulate something called these retinal ganglion cells in your retina, and it's going to send a signal to the suprachiasmatic nucleus. And it's the suprachiasmatic nucleus, or the master clock of your body that regulates all the clocks in your body, is going to determine whether or not your circadian rhythm is where it should be, or whether it's slightly delayed, or whether it's slightly advanced. And that can cause problems. So we need to make sure we understand this. Of course, as we know, light that hits the eye also goes back to the back of the brain, called the occipital cortex. That's where you see things. But specifically in this talk, we're going to be talking about the suprachiasmatic nucleus. Now, it also shows there, and we'll talk about this when we talk about light, that light that hits the back of the retina will also shut down melatonin that is produced in the pineal gland. Now, the pineal gland produces this melatonin, and it's important for sleep because melatonin is one of those things that goes throughout the body after it's secreted from the pineal gland and tells your cells it's time for sleep. So this is really important. Now, if we look at our graph again, we'll see that we've modified it in a way here to show you that melatonin is produced at night, right before you're about to go to bed, and it's telling the body and it's getting it ready for sleep. But one of the things that will shut down melatonin production is light. And so if you expose your eyes to bright light at night, right before you go to bed, you're not going to get as high a melatonin production as you would normally do. And as we'll talk about, that can be very bad. The other thing that light exposure at night will do is it will affect the circadian rhythm through the suprachiasmatic nucleus. And what it does specifically is it delays your red, as we see here, circadian rhythm. In other words, instead of your body being ready to go to sleep, let's say at 10 o'clock at night, if you're exposing your eyes to bright light, it's going to move it over a period of time from 10 o'clock to maybe 11 o'clock, maybe even 12 o'clock, so that your green homeostatic drive may be ready for sleep at 9 o'clock, but your circadian rhythm is not going to be ready for sleep until much later. Now, of course, if it's shifting it and it's delaying it, that means instead of being ready to wake up in the morning at 6 o'clock, it might not be until 7 or even 8 o'clock that happens. And so that can have consequences, as we'll talk about. So sleep is not just an on-off switch. It's not like you go to bed and you flip off the switch and you're resting for 8 hours and then you come back on. There are processes that are occurring in the body very actively while you are sleeping. And they're happening in the brain, they're happening in the body, and all over. So what is it about sleep? The first part of sleep, let's divide sleep into two phases. There's the early portion of sleep. Occurs between when you first go to bed and perhaps maybe 2 or 3 in the morning. And then after that, there's the second phase of sleep, what happens maybe after 3 or 4 o'clock and occurs until 5 or 6 when you get up the next morning. And it's really more of a gradation. It's not a specific early and then late. And as we'll talk about here, we can show you here that there's something called a hypnogram, which is a graphic representation of sleep. As you can see here, is that there are different stages of sleep. So there's the awakening stage, which is at the top. And then as you go into deeper and deeper sleep, it goes all the way down to stage 1, stage 2, stage 3, and even stage 4. Now, today scientists have grouped together stage 3 and 4 together, and they call that slow wave sleep or deep sleep. Notice that the deepest sleep of the night is at the earliest portion of the sleep period. And this is the portion that we associate with growth hormone secretion. Growth hormone secretion is very important in terms of making you grow and also making you feel younger. We notice that as people get older, they don't secrete as much growth hormone. And so what we do is we associate growth hormone with sleep. And this is the physically restorative sleep that we see early in the night. Now, as we move on, we'll notice that there is more of this REM sleep. REM sleep is also important as well, but it's important for different reasons. REM sleep is the portion of the sleep where you get consolidation of memory and your ability to remember things. And it's also during this period of REM sleep, toward the later portion of the night, that you get dreams. Now, this is important. When you dream, you don't want to be acting out your dreams. And the way that the body has of fulfilling that is that it basically paralyzes your body. It shuts down, it disconnects your brain from your body. So you can be dreaming, you could be running, something's chasing you and you're running, or somebody's attacking you perhaps in a dream, and you're not going to act that out with the person next to you in bed because you're detached from your body. And that's a very important aspect of REM sleep. You have paralysis. It's temporary. There's some conditions where actually that doesn't happen, where they continue to act that out. But generally speaking, REM sleep is where you're paralyzed and you're dreaming. And that's important to have. But that's more towards the latter portion of the night. So early portion, latter portion, different functions, different aspects to it. You can imagine what would happen if you didn't get to sleep early enough. Which one would you lose out on? You would lose out on some of this early sleep, this slow wave sleep, this physically restorative sleep that you have at the beginning. And as you can see here with our hypnogram, again, delta sleep toward the beginning, REM sleep towards the end. And you can see what aspects of that occur. So going back to our stages of wakefulness and circadian rhythm, let's put up a scenario that's very common that I want to talk to you about. And I think it's happening far too often in our country. We have students, we have people who are working, and what happens? They come home at night and they're studying, they're up late, they're on screens. We'll talk more about this when we talk about light exposure and light in general. It takes just a small amount of light to shut down melatonin production in the pineal gland. And in addition to that, it also just takes a small amount of light to delay the circadian rhythm, the red line that we see on this graph. And what would happen if we delayed the red circadian rhythm aspect of our sleep is, as you can see here, it would become the pink line, which is more delayed. Notice what happens at the time of sleep. The pink line is below the red line, which means that the drive to sleep is not there. And notice also in the morning time, what would happen is that the drive to sleep would be higher. And so what happens is people have insomnia at night. They can't go to sleep. They're not getting good night's sleep at night. And they're not getting that slow wave sleep at night. And in the morning time, they're trying to wake up because their alarm is telling them it's 6:30. You got to get up. You got to get to work. You got to do that commute. And they're not getting the rest that they need. They're getting cut short. And so because of that elevation in the sleep urge, because the circadian rhythm is shifted from the red line to the pink line, they're not going to be as awake. They're not going to be as alert in the morning time as a result. And so one of the major aspects of sleep deprivation is exposure to light at night. And we'll talk more about that in our light series as well. But this is important in terms of sleep. So quality of sleep is important. What about quantity of sleep? Well, a number of studies have been done on this, and we have recommendations from the American Academy of Sleep Medicine. And just very briefly here, if you look at people who are age 14 to 17, the recommendation is that they should be getting 8 to 10 hours of sleep every night. Hey, I've got somebody in that age group. I have a daughter who's 16, just turned 17. And boy, I would be surprised if she's getting 10 hours of sleep, maybe barely 8 hours of sleep. This is really difficult to do, especially when students have to go to school. They start school at 7, 8 o'clock in the morning. Here in California, we just had a recent legislation that moved high school times to a later hour at 8 to 9 o'clock in the morning so that they can get that sleep that they need. But unfortunately, as adults who work, we don't have that same benefit. How much sleep do we need? Well, we can see there that the 18 to 25-year-olds, the recommendation is 7 to 9 hours of sleep. That's the same, by the way, for 26 to 64-year-olds. As you can see on this graph, as you get older and older and older, the amount of sleep that we need to have is less and less. It's true. But if you look at the average American's sleep, it's anywhere between 5-6 hours of sleep per night, well below the bare minimum of recommendation, which is 7 hours of sleep. And this can have actually some pretty significant effects. Again, let's look at that immune system that we talked about, the adaptive immune system, the body's ability to make antibodies. Here's a study that was published in the Journal of the American Medical Association where they took 25 subjects and they randomized them to sleep versus sleep deprivation, and then they gave them the flu shot. Then they measured the antibodies as a result of that flu shot. And in those people that only had 4 hours of sleep, the antibody titer was 0.5 units, whereas those that were able to sleep as long as they wanted to had 1.15 units of antibody. So essentially, getting a good night's sleep before vaccination meant that you had twice the antibody level, just based on sleep alone. We're not even talking about diet. We're not talking about exercise or any of these things, just based on sleep. And that was impressive enough that the authors of that study said the following: these results indicate that the response to influenza vaccination is likely to be impaired in individuals who suffer from chronic partial sleep restriction. Because adults who show poorer responses to vaccines and other antigenic challenges also experience higher rates of clinical illness, our findings support the concept that adequate amounts of sleep are needed to maintain resistance to infectious challenge. Now, this is not the only study that looked at that. There was another study that looked at the quality and the quantity of sleep that these patients had. So this was a larger study, 153 subjects, and it was a prospective trial. And they basically, at the end of this trial of them sleeping 7 versus 8+ hours in terms of their history, they asked them, they did questionnaires of these subjects and said, how long are you sleeping for? And so based on that, they prospectively put little rhinovirus drops in their nose. You can imagine the types of subjects that we're talking about here. These are college students, right? So they put rhinovirus drops in their nose. And those that got 7 hours of sleep or less, okay, as opposed to 8+ hours, had 2.9 times the risk of getting a cold. And those that had less than 92% quality of sleep, when we talk about 92% quality, the total amount of hours that they spent in bed in the denominator, and the number of hours they actually slept in the numerator, if that number exceeded 92%, they were 5.5 times less likely to develop an infection. So you can see here that it's not just quantity, but it's also quality of sleep that's important. And so the authors of this study said, because of the prospective design and the controls for multiple confounding variables, these results strongly suggest the possibility of sleep playing a causal role in cold susceptibility. So again, really important here that you're getting enough sleep and the quality of sleep as well. So one of the things that we talked about earlier on was melatonin. And melatonin is one of those substances that is secreted from the pineal gland. And if you expose your eyes to bright light at night, melatonin from the pineal gland is not secreted, and you're not having that going throughout the body. Now, melatonin is felt to not only be a sleep signal, but it's also been shown very definitively to be a very powerful antioxidant. And in this study, it shows that melatonin in vitro, in the test tube, can block not only the spike protein of SARS-CoV-2 virus, but also block the ACE2 receptor, and potentially they're looking at studying to see whether or not higher melatonin levels can also block the virus infecting of SARS-CoV-2. So if you want to have melatonin in your body, rather than taking a supplement, which is going to send the signal to your body that it's time to sleep, much better to have the pineal gland produce it in the amount that is needed at the time that it's needed with your circadian rhythm on track. So let's talk about sleeping and studying. So oftentimes what happens is students and even adults will decide to say, hey, you know what? I've got too much work to do. I'm going to pull an all-nighter. How many of us have done all-nighters before, right? And we say, well, it's just once. It's not going to really hurt. There was a study that was done that was published in the Proceeds of the National Academy of Sciences, published back in 2018, where they actually did a study and they followed students who pulled an all-nighter. And they followed hundreds of different proteins in the body to see what would happen. These are very important proteins that are involved with immunity, involved with cancer fighting. And remember I told you before that the suprachiasmatic nucleus in the brain is the master clock. It's the master clock that dictates what happens throughout the entire body. And it regulates the clock in all of the cells. Well, if that is off, if you're exposing your eyes to bright light at night and that master clock is not working correctly, then these proteins in the body, which have a specific cyclic secretion to them, are going to be off as well. And so when they're supposed to be high, they might be low, and when they're low, they might be high. So let's see what happened in this study that they did. They took 6 healthy men in their 20s. They stayed at a research center. There was no cell phones, no screens. They slept for 2 days at night, which is the baseline. And then they transitioned into staying awake at night and then sleeping during the day, as well as eating also in the night. So they did a complete switch around. So imagine you've got this test the next day. You're going to pull an all-nighter. You're going to study it. You're going to cram for it. Or let's say you've got a job and you've got a presentation due the next day, and you stay up all night trying to work on this thing, and you show up the next day and you give this presentation that you worked on all night. What's the consequences of all of this? So they took blood samples every 4 hours of over 1,129 different proteins. What they found was very interesting. About 10% of these proteins switched their peak time. So in other words, instead of peaking at when they were supposed to peak, they didn't peak at that time. And many of these changes had occurred even after just one night of pulling an all-nighter. So what kind of proteins are we talking about? Well, one of them was glucagon. Glucagon is one of those proteins and hormones of the body that's secreted by the pancreas that regulates glucose metabolism. And it rose higher at night than would have normally have done at the daytime. And this is a risk for diabetes when you have glucagon levels that are that high. What about FGF19? That's a protein that we're not really familiar with, but it's a protein that we'd all be very interested in if we wanted to lose weight, because FGF19 is one of the proteins that's involved with calorie burning. It boosts your body's ability to burn calories. And this protein was decreased in these students that actually pulled the all-nighter. And so what happens to your basal metabolic rate when this happens? Obviously, it's going to go down. So this is a risk factor for weight gain. So staying up late can increase your weight through this potential mechanism of FGF19. So the authors of this study said that staying awake at night and sleeping during the day for even just one 24-hour period can rapidly lead to changes in more than 100 proteins in the blood, including ones that have an effect on blood sugar, immune function, and metabolism. And over time, these biochemical changes in blood protein levels can elevate your risk for health issues such as diabetes, weight gain, and even cancer. And this was the lead author, Dr. Christopher Depner, who is a postdoc fellow in the Department of Integrative Physiology at the University of Colorado in Boulder. So clearly, pulling an all-nighter is not good for you in terms of the havoc that is wreaked in terms of your body's metabolism. It would be much better for you to go to bed early and wake up early in the morning and try to work on that project or study. Because during the night, there's a lot of organization of your thoughts and your body's ability to study and to retain information. In fact, your body's brain actually slows down at night. And so trying to do things during the night is not a good idea because you're not getting the full efficiency. It's like trying to swim upstream. So it's better to go to bed early and wake up early if you've got something to do that needs to be done before the morning. Let's talk a little bit about what we've talked about before, which is this slow wave sleep. Now, we've said that if you are exposing your eyes to bright light at night or any kind of light in general, it's going to shift your circadian rhythm, it's going to delay it, and it's also going to shut down, very importantly, this melatonin production that signals your body that it's ready for sleep. And you're also going to lose out on that very first portion of sleep, which is that slow wave sleep. So a number of things have been written about this. One of them, a sleep consultant from the UK, Dr. Simon Kyle, wrote this: "It's actually during the first third of the night that we experience the deepest part of our sleep. We move into deep sleep more rapidly, and it's the phase of sleep during which we're least likely to be disturbed and wake up. This deep or slow wave sleep is the most restorative part of our sleep. We experience low levels of stress hormone cortisol, as we've talked about before, as well as reductions in the sympathetic nervous system activity. This is the stimulating activity associated with our fight or flight responses. We also experience increased parasympathetic nervous system activity, which is associated with rest and digest activity." So you can see why it does the body so good. Slow wave sleep is also associated with memory consolidation, our learning ability, and overall alertness the next day. The emerging picture from experimental research is that slow wave sleep is involved in critical aspects of cognition and daytime functioning, and that it assists in keeping our brain and body in optimal health. If you're waking up unrefreshed, it's likely that your deep or slow wave sleep is suffering in some way. Avoid taking naps because deep sleep is related to the amount of time spent awake. In other words, the more time you spend awake during the day, the better able you are to get that big boost of slow wave sleep at night. So to take steps to reduce your pre-sleep stress as well, because pre-sleep stress can also reduce your body's ability to get slow wave sleep and that deep slow wave sleep that you need at night in the first part of sleep. So let's talk a little bit about how do you know if you're not getting enough sleep. As we talked about at the beginning, teenagers, adolescents don't hide their ability to be sleep deprived. In other words, they can fall asleep very easily when they have chronic sleep deprivation. Adults, on the other hand, people who are older, can hide it very easily. We can have adults that come to the doctor's office and they can be asked, I ask them all the time, are you feeling sleepy? They feel fine. They don't know that they're actually chronically sleep deprived. So one of the things that I want to do right now is to sort of go over a questionnaire to see whether or not you feel, first of all, do you feel like you're sleep deprived? And then let's find out if you actually are sleep deprived. And I have a list here, and all you need is just 3 to say yes to 3 of these statements, and you are at risk for chronic sleep deprivation. So let's go over these real quickly. I need an alarm clock in order to wake me up at the appropriate time. I mean, who doesn't, right? These are you're going to be saying here, wow, these are really easy questions and really easy to say yes to. But if it's just 3 or more, the studies have shown that you are at risk for being chronically sleep deprived. Is it a struggle for me to get out of bed in the morning? Weekday mornings, I hit the snooze button several times to get more sleep. I feel tired, irritable, and stressed out during the week, right? Who doesn't, right? I had trouble concentrating and remembering. I feel slow with critical thinking, problem solving, and being creative. I often fall asleep watching television, at boring meetings or lectures. Hopefully this is not one of those. Or in warm rooms. I often fall asleep after heavy meals or after low dose of alcohol. I often fall asleep while relaxing after dinner. I often fall asleep within 5 minutes of getting into bed. That's what we call a very short sleep latency. That's the time it takes for you to fall asleep after getting into bed. I often feel drowsy while driving. Now that's obviously something on its own that's very dangerous because a lot of accidents can happen when people fall asleep. I often sleep extra hours on weekend mornings. That's when you don't have that drive to have to go to work. What do? If you are sleeping in, chances are you're sleep deprived. I often need a nap to get through the day. And that means that you're so sleepy that you've got to get a nap. Now, what happens, by the way, when you take a nap during the day is that adenosine levels, which are climbing as you're awake during the day, when you take a nap, they suddenly go down slightly. And then after the nap, they start to build up. So that what happens is toward the end of the day, your adenosine levels are not as high as they would have been if you hadn't have napped. Now, I'm not saying for everybody not to nap, but if you're having problems falling asleep at night, one of the things that I would recommend, and we'll talk about this later, is not napping. I have dark circles around my eyes. This has to do with lymphatics and drainage and things of that. So add all of those up. How many times did you say yes to those? If it was 3 or more times, the chances are you are probably chronically sleep deprived and need to get more sleep. Again, how much sleep should you be getting? American Academy of Sleep Medicine has given us some recommendations. For most of us that are listening to this, we're going to be at least 7 hours of sleep. And you'd be surprised how many few nights in a month you'll get more than 7 hours of sleep. Remember that exposing your eyes to bright light is going to shift your circadian rhythm so that what occurs is you're going to feel less sleepy at night. You're not going to have melatonin production at night, and you're not going to have the same number of hours. And so one of the things that I would highly recommend for sleep, and we'll talk more about this in our light lecture as well, is after the sun goes down, especially after 9 o'clock, is to have dim lighting or no lighting if possible. Obviously, if you have to do something, you don't want to be falling and tripping over yourself. So having low-level lighting on the floor or on the walls low down, and to especially avoid blue light, which is the type of light that specifically and most efficiently causes the excitation of the ganglion cells in your retina, which shuts down melatonin production. So having more reddish light, having it low, having it dim, these are the sorts of things that you want to do. The other thing to do, of course, is to avoid getting on your computer, avoid getting on your smartphone. These sorts of things, especially after 9 o'clock at night, are going to delay your circadian rhythm, so you're not going to bed as early. And it's also going to shut down melatonin, which is very beneficial. Some other things that we could talk about as well in terms of sleep hygiene is because your circadian rhythm is on a regular cycle, you want to maintain a regular sleep routine. Don't do something during the week and do something different on the weekend. If you get up at a certain time during the week, get at that certain time on the weekend. As we talked about, if you're having trouble falling asleep at night, avoiding naps is also very beneficial. Don't stay awake in bed for more than 5 to 10 minutes. Why is that the case? Well, if you're having trouble falling asleep, you're going to associate your bedroom with the anxiety of having insomnia. We don't want that to happen. We don't want you walking into the bedroom and associate your bedroom with not being able to sleep, because then your heart rates are going to go up, your sympathetic nervous system is going to go up, and it's going to be impossible to fall asleep. So if you're having problems with insomnia, don't stay in bed for more than 5 or 10 minutes. Get out of bed, go to a different room of the house, have your insomnia associated with that room of the house, not the bedroom where you're trying to go to sleep. Don't watch television in bed, okay? Don't do other things in bed other than sleep, because you're going to associate the bedroom with those things. So if you go into the bedroom and your brain is saying, oh, is it time to sleep, or is it time to watch television? Or it could be time to read, or it might be time to work. No, I want you to walk into the bedroom and I want your brain to say, it's time to go to sleep. And we want all of that drive, that subconscious drive and association with you going to sleep, especially if people have insomnia. Avoid caffeinated beverages. Why? Well, because caffeine, what does caffeine do? Caffeine will actually interplay with the adenosine receptor. That's why it makes you feel like you're more awake. The problem is that because it blocks it, that it will also cause an issue later on in terms of trying to fall asleep at night. And so we don't recommend drinking caffeinated beverages, especially if you have a problem with insomnia. Exercise is really important. So exercise during the day is going to help you fall asleep at night. And I would even say this, is that we've sometimes recommended against exercising in the evening, but I'll say this, exercise in the evening is better than no exercise at all. So morning exercise is the best. Evening exercise, no exercise is the worst. But if you're having trouble falling asleep at night, doing some sort of exercise on a regular basis, and we'll talk more about that in our exercise video, is going to be very beneficial for getting you back to sleep. And if you're one of these clock watchers, you know, oh, it's 11 o'clock. Oh, it's 11:15. I haven't gone to sleep. Get rid of the clock, okay? Unless you need it for an alarm. And if you do, we know that you're sleep deprived. Get rid of the clock, cover it up so that you're not watching the clock, because that just puts your brain into a mode of watching the clock and not falling asleep. And really, what you want to do is get into a routine, a comfortable pre-bedtime routine where you can go into a hot bath. That's also very beneficial, because what that does is it raises your body temperature. And we'll talk more about this again when we talk about hydrotherapy. So raising your body temperature as it starts to cool down, that tends to also help the body fall asleep. As we know this from looking at circadian rhythms, is the coldest that your body temperature ever is around 3 or 4 o'clock in the morning. We call that the temperature nadir. And as your body starts to cool down, being in a cool room, these are all things that are conducive to falling asleep. So what we've talked about today is sleep. Now, we could talk for hours and hours about all of the different types of sleep problems, but I feel that this is a good foundation, and it's very low-hanging fruit for how somebody who has a problem sleeping can eliminate a lot of the barriers that we have in society today to getting a good night's sleep. Let's review those once again. Number one is making sure that we're not exposing our eyes to as little light as possible after 9 o'clock at night. So by doing that, that's going to do two things. Number one, it's going to help us keep the circadian rhythm in line with what we want, as opposed to delaying it, number one. And number two, it's going to make sure that melatonin is being secreted appropriately at night, and we get the health benefits of that melatonin. The third thing that I would mention as well is making sure we're getting enough sleep. So by going to bed earlier, that problem is going to be solved in a lot of situations. Think about this. If you go to bed at 10 and you have to wake up at 6 in the morning, you're going to be getting at least 7 hours of sleep, depending on how long it takes for you to fall asleep. So I hope this has been helpful, and join us for more.
Hey, I'm glad you enjoyed this lesson. We have more lessons on the way, so click the notification bell below so you don't miss our weekly videos. I'll see you there.